What's up, guys? So today we're gonna do inheritance. So let's do inheritance. Before you start, be honest with yourself. Do you really understand recursion? Do you understand pointers? This is a hard lab and a hard problem set. So if you're still not comfortable from the previous exercises, I recommend you take a look at CodingBet. So the link to CodingBet is on the description. It's a great website created by a Stanford professor where he basically goes through small snippets of code that help you get a good foundation into code. Under Java, I know you're doing C, not Java, but the code is pretty similar. You don't need to learn anything. Just coding C, the first 8 problems here that I'm highlighting, and you get a very good practice with recursion. Once you're done that, go back to Tideman. We have the solution in the link on the description as well, and a video here on the YouTube channel. Try that out. Make sure you understand that and then go to this problem set. So I really recommend only going through that when you are comfortable. So without further ado, let's take a look at inheritance. So inheritance, I want to show you the OneNote now, just so you get a better understanding. So now let's take a look at OneNote. So what we have is basically this figure over here. So we're basically building a family tree. How does this family tree look like? What it has is basically a child, represented here by the baby. That baby has an array with 2 elements. Those elements will be chars, and they will have pointers to parents. How do I like to represent this? Like that, like here, where I'm highlighting. I have basically a field here at the bottom, which has my alleles. Is an array with 2 elements. And then I have an array of pointers. This is something that looks really complicated, but it's not. If you draw, it doesn't really look that complicated. You create 2 fields and create an arrow pointing to parents. Those parents will also have their own alleles and their own parents, so on and so forth. So by the end, we'll have a tree, a family tree. More specifically, a inverted tree. If you look like that, if you start continue building this tree, it will start looking like an inverted tree, right? So the way we're gonna build this is by using recursion. Take a look at this example here. This will be our base case. So this will be only a family with only one person that doesn't have any children and doesn't have parents. So let's say it has AO. So we'll have to set the pointers of both parents to null. We represent null with these little squares. And also we'll choose the alleles randomly. There is a function, if you look at the code, there is a function called, let me take a look, random allele. So you're gonna call random allele. That will generate you this random allele, and you put this in this base case array. So what if it's not my base case? What if I have other elements? Then I'm gonna call this recursively. So then let's say I have a certain alleles, like that. So how is the recursion gonna work? I'm gonna see that I have this node here that I'm pointing. Let me not use an arrow. Let me use a different color. This node here has 2 parents. So then I'm gonna recursively go to each parent until I'm at a point where those parents don't have parents. They don't have parents of their own. So this one won't have parents. Let's say it's only 2 generations. Observe that these parents here, they fall into our base case, right? The base case is when the current person doesn't have any parents. So then this will fall into the base case. This will generate random alleles. Let's say, let's copy that. So OOAB. And now that I'm done with the base case is gonna get returned. And then my child we'll basically get its alleles from randomly from 1 and randomly from 2. So we'll have basically to access our first parent, use some random function to either pick the first allele O or the second allele O, and then put this here. And then we'll do the same thing for 2. We pick randomly A and B, and that will be my current allele. And by the time I return from this function, it's gonna be, we're gonna be done. Okay? So now let's go back to the problem here on CS50 IDE. Let's actually build this. So let's quickly look at main. Main creates, this is for our random function. This will call the create family, which we'll be implementing. We're gonna print the family and then free the family from memory. So let's start with the base case. So the base case is when I'm at generation 1, meaning the current person doesn't have any parents. But before that, let's create the current person. So we need to create a person type. This is the type of the struct, right? On line 14, you can see this is a person. We're gonna create a pointer to that person, so we need to allocate memory.